Hello everyone. Our chapter motion in a plane. Previously we are introducing position and displacement. Okay. Right. What is the definition of position? The position means we are taken path length, and displacement we are taken the rate of change of the position means. Okay. The rate of change of the position, which is known as displacement also. The same definition we are introducing the shortest distance between any two particles or initial velocity to final velocity. This phenomenon is known as displacement. Previously we are introducing the graph position also we are introducing. Okay, write our chapter motion in a plane. Motion in a plane. Now this motion in a plane, we are introducing our topic velocity. Previously we are introducing some motion in a plane. The topics are in motion in a plane. The topics we are introducing position and displacement. Now next one velocity, and next one acceleration. These three things we are introducing in our motion in a plane. Clearly we can observe. First one, which is completed, position and displacement, our previous one. Okay, today we are discussing about our topic velocity. Clear one? Velocity. Now what is the definition of velocity? Previously we can already know that. Okay, our chapter motion in a straight line also. Okay, then we are going to velocity, the rate of change of displacement. Which one? Displacement is known as velocity. Okay, right, we are going to velocity means the rate of change of displacement is known as velocity. Clearly, the velocity, what is the equation of velocity? Now velocity is small v is equals to displacement by time period. The rate of change of displacement is known as velocity. The rate of change of displacement is known as velocity. This phenomenon is known as velocity. Okay, we can observe velocities are mainly two things. Now first one is average velocity. First one means average velocity. Right, we are going to average velocity, the sum of statement and typical property. Which property? The typical one of the property. Right, we are going to topic average acceleration. Now what is the definition of average acceleration? So average velocity. Okay, now velocity means we introducing to these positions of average velocity. Now average velocity means, okay, the ratio of displacement and time period. Okay, the ratio of displacement and time period. The ratio of displacement and time period is known as average velocity. Okay, now we are taken average velocity. Average velocity is equals to, say we are taken displacement by time period. Which one? Time period. Now this fundamental definition or phenomenon is known as average velocity. In this average velocity, we represented some graphical statement. For example, I put this is the one of the graphical statement from x-axis to y-axis. X-axis to y-axis. Okay. We are introducing this position we can be maintained as. Okay. So this is the, for example, curve we are introducing. Okay. This is origin point O. Okay, there are the position which can be average velocity. Velocity means displacement. Displacement means also position we are taking. The position we can represent it to this curve point. Okay, the first position we can take as P1 position. Okay, now this is the direction. Now second position, this is the P2 position. Okay, these two interpretations is known as, clearly, this is the delta V. Clear one? The velocity delta V. This is the R1, this one is R. The distance we are taking, the first one r1 and second one r2. The velocity we can represent it as v1 and v2. Average velocity means the distance of these positions we are taking. Okay. Now r1 and r2, there are two positions. We can get it into this side is called as delta v position. Delta v means we are taking the average velocity. Okay. Right. The phenomenon is of the position we are taking is taken. Delta v is equals to which we are taken delta r by delta t. Clearly one. This one also we are taken delta r also. We can take it. Delta v is equals to delta r by delta t. In x-axis we can reduce it. In y-axis also we can reduce it sum of portion. Clearly. Okay. Now delta v is equals to delta x into I cap plus delta y into j cap by delta t. Delta v is equals to at x-axis of the position delta x into I cap plus y-axis of the position delta y into j cap by the represented time period delta t. Clearly, okay. The separated of the values of delta v is equals to delta x into I cap, okay, delta x into I cap by delta t plus delta y by delta t into j cap, okay, delta x by delta t into I cap plus delta y by delta t into j cap. The rate of change of displacement is known as velocity. The rate of change of displacement is known as velocity. Now delta v is equals to v1. Okay, right now v1 into I cap plus v2 into j cap. Okay, this is the average velocity. Now delta v is equals to v1 into I cap plus v2 into j cap. Now this is the average velocity. Now we can take as magnitude of the average velocity. Clearly one. Magnitude of the average velocity, the magnitude of average velocity into v mod, okay, mod v1 is equals to square root of vx square plus vy square. Now this is the magnitude of the average velocity. Okay. Now what is the direction? The direction means which can be applicable. Okay. The same as average velocity is equals to same as average displacement. Average velocity is equals to average displacement is known as. That's how we can take the direction of the property. Now this is the average velocity. It can be mainly applicable in this average velocity through to continue to the next level is instantaneous velocity. Now what is instantaneous velocity? How we can applicable in graphical method? Clearly, okay, right? We are going to instantaneous velocity. Instantaneous velocity. Okay. Now, what is the definition of average velocity? Clearly, now average velocity is equals to which one? Which one? Displacement by time period. The same one also we are taking. Velocity is equals to displacement by time period. Average velocity is equals to displacement by time period. Now, instantaneous velocity is equals to displacement by time period also. These the phenomenon or fundamental positions we make. Clearly, okay, right. Now next one. Now the next topic, instantaneous velocity. Instantaneous velocity. Instantaneous velocity. The same definition will continue to velocity, average velocity, and instantaneous velocity. Right? We can introducing our instantaneous velocity. Also, the ratio of velocity and time period. Clearly, we know that velocity or average velocity and time taken. Clearly, the ratio of average velocity and time taken, which is known as instantaneous velocity. Okay. Now, instantaneous velocity is equals to displacement average velocity. Okay, right one. Average one we are taking the displacement, the ratio of instantaneous velocity. Clearly, we can know that the same situation will continue to in average displacement also we are taking. Clearly, know that average displacement. Displacement. Okay, average displacement by time taken. Average displacement by time taken. This phenomenon is known as instantaneous velocity. The sum of graphical positions we can introduce. Okay, now graphical. There are three types of positions we can applicable. Okay, right? Now first one. This one is x-axis. Now this one is y-axis. X-axis, y-axis. Now horizontal. Clear one? Okay. Sum of r we are introducing. Clear you know that? Okay, this is the first position. Our previous one we are introducing P1. Okay, it go to P1. Now first one. Now this one P2 position. Okay, it go to P2 position. The same we can introduce. Okay, now this is the delta R, R1, R2. Clearly, you know that the position we can change this. There are two different ones. The different positions we can apply. The sum of simultaneous distance. Okay. Now second. This one is x-axis to y-axis. X-axis to y-axis. Same one we can introduce in horizontal. Okay. Same arc will be continued to a secondary position. Okay. This is the position P1. Have to go to P1 position. This one. Have to P2. The sum of acceleration. This is a P2. This one is delta R. It R1 at R. Clearly? Now third. Third graph at x-axis to y-axis. Same arc will be continued. Okay? Same arc. R is in point. The position is going to R. Now at first position. Clearly? Okay, we can observe to the R. Clear? Now this is the position P1. Only position we are taken. The shortest displacement one we have been taken. There are two different ones. The flexibility of different ones of the these positions. There are shortest one. This is the similar one. Only we can take as the similar one. This is the one. This is the again also one we can take now. Okay. This is the R1. Clearly R1. Now these the position is known as tangential position. Which position? Tangential position. Tangential means we can take it that theta is equals to tan property also. Okay. Now instantaneous means at instant of time period. Which one we have taken? Instant of time period. Instant of time period. Now instant time period means we can applicable to its shortest one we can introduce into. Again also we can introduce into the same point which is known as instant of time period or instant of velocity. Now we are applicable the ratio of average displacement and time taken. The time taken which can be applicable instantaneous. Now we can take instant of time. Instant of time. Made of instant of time is known as instant of velocity. Clear we know that the first one, the position P1 to P2, there are two different types of positions in longer one. The shortest one P1 and P2. The only similar we can take as the only one position to starting position at the same one, ending also same one. This one we are taken that P1 position. Now this one is tangential position we can applicable to. This one is known as instantaneous velocity. Instantaneous velocity. Now what is the parameter of instantaneous velocity? Okay. Now we can applicable and magnitude and direction also. Okay. Now magnitude of instantaneous velocity. Okay. Right. We are going to magnitude of instantaneous velocity. Now what is the magnitude? Clearly our previous one we can introduce to the same one also. Okay. Now magnitude and direction we can introducing our topic. Which topic we are introducing? Parallelogram law. Clearly, you know the parallelogram law. Now what is the magnitude of parallelogram law? R is equals to square root of a square plus b square plus 2ab cos theta. Now what is the direction? Now direction tan theta is equals to or theta is equals to tan inverse of b sin theta by a plus b cos theta. A plus b cos theta. This phenomenon is our parallelogram law. Today we are our topic. Now velocity, average velocity, instantaneous velocity. Some of consequences of. Okay. magnitude of instantaneous velocity. Magnitude of instantaneous velocity. Here instantaneous means instant of time period. Instant of time period. Okay. Now delta V. Okay. They are applicable. The limits delta V. Limits of delta V. At V position we are taken. At delta T tends to 0. Okay. Limit T tends to 0. The limitations of delta V we can applicable delta T tends to 0. Okay. Now we are taken as limits of delta T tends to 0, delta R by delta T. Clearly, the rate of change of displacement is known as velocity. The way we are applicable average displacement is known as average displacement. The rate of change of average displacement is known as average velocity. An instant of particular time is known as instantaneous velocity. Here is the limitations of delta V, delta T tends to 0. The limitations of delta T tends to 0, delta R by delta T, which is known as instantaneous velocity. Clearly, we know that dV by T. dV by dt. Clearly, there are two synchronized positions at x-axis to at y-axis. Now, x-axis representation. Clearly, the limitation of delta T tends to 0. Delta x in by delta T into I cap. Okay? Clearly, let's say one total representation of this position. Clearly. Delta x into I cap plus delta y into j cap by delta t. This is the phenomenon. Okay. The limitations of delta v. Delta v means we are taking velocity. Now velocity is equals to the rate of change of displacement is known as velocity. Here we know that the instant of time period dv by dt. This is the position of time period. Here we can take it the limits of delta t tends to 0 clearly. Okay, at x-axis to y-axis the position which can be reversed at I cap to j cap unit vectors. Clear? Now delta x into I cap plus delta y into j cap by delta v. The separation of these terms. Okay? Now limits of delta t tends to 0. Okay? Delta x by delta t into I cap, the first one. Plus delta limits. They are applicable limits. Limit delta t tends to 0, delta y by delta t into j. Clear? Now limits of delta t tends to 0, delta r by delta t. The rate of change of displacement is known as velocity. The same way we can continue to delta v by delta t or dv by dt. Clear one? Okay. Now dv by dt at x-axis into I cap. Okay. Into dvy by dt into j cap. dvx by dt into I cap, dvy by dt into j cap at x-axis to y-axis. Clear? Now this the formation is known as we can take it as that once we can introduce it. The rate of change of velocity. Clear one? Delta x by delta t. Sorry one. Delta x by delta t. Delta x by delta t. Same one. Delta x by delta x. Delta x by delta t. If this one is y-axis, we are taking at y position delta dy by dt. Same. Now this the phenomenon is known as velocity. At x-axis to I cap, at velocity y-axis to j cap. Now velocity v fundamental we are taking. Clearly one. Now this is the instantaneous velocity at vx into I cap plus vy into j cap. Okay. Now magnitude of this one we can take it as now v mod of is equals to square root of vx square plus vy square. Vx square plus vy square. This is the magnitude. Now what is the direction? The direction of which one? Instantaneous velocity. Direction. Okay. Now direction of velocity. In tan theta is equals to at velocity of y-axis by velocity of x-axis. Now theta is equals to tan inverse of vy by vx. This is the direction. Clearly? R means we can reduce it to the position we can take in as displacement, or the rate of change of displacement is known as velocity. At displacement we can take in there are two positions at x-axis to y-axis. The next elements you can take in as I cap, j cap, y limits. Okay. Now summation of this delta x by delta t, delta y by delta t. Clearly we know that delta x by delta t is equal to, similarly we can take it as an instantaneous velocity dv by dx by dt, dy by dt. Clearly the rate of change of velocity, so displacement is known as velocity. The rate of change of displacement is known as velocity, the x-axis to y-axis. Now this is the magnitude of this one. Now v bar is equal to, the mod of v bar is equal to square root of vx square plus vy square. Clearly we know the direction. We can take it as always secondary purpose. We can use it to our previous one which can we can take it as a parallelogram law. Clearly we know that it's secondary position by primary position. Now secondary position we are taking as vy by vx. Now theta is equals to tan inverse of vy by vx. Now this one is known as velocity. Clearly one velocity. Okay. Now we are going to next one, acceleration. Clear one. Previously we can upload our video position and displacement. Today this video is velocity. The velocity is mainly two things. The first one average velocity, second one is instantaneous velocity. Same one you can use it acceleration. Which one? Acceleration. Now what is acceleration? Previously we know that our previous class, acceleration means the rate of change of velocity is known as acceleration. The rate of change of velocity is known as acceleration. At the same time, we are introducing our two kind of accelerations. There are two kinds of accelerations. The first one, average acceleration. Second one, instantaneous acceleration. We can get it into same graphical manner also using. Okay. Now graphical applicable. There are three kinds of informations. Okay. Acceleration. Now what is the definition of acceleration? I can told you always. Clear one. Acceleration means the rate of change velocity. The rate of change of velocity is known as acceleration. Okay. Now acceleration equation A is equals to v by t. A is equals to v by t. The rate of change of velocity is known as acceleration. Clearly we know that accelerations we are introducing our secondary one, average acceleration. The next one, instantaneous acceleration. This is the secondary. This is the primary one, acceleration. A is equals to v by t. Next we can introduce our topic, average acceleration. Previously we know that the same one, average velocity. Clear one? Now today we are introducing our this one topic is average acceleration. Now what is average acceleration? Now what is the definition of average acceleration? Now what kind of definition? Clearly we know that previously we know the definition of acceleration. Same one. Average acceleration. Now average acceleration means the ratio of velocity and time. Clearly, the ratio of velocity and time. Average acceleration means the ratio of velocity and time period is known as average acceleration. Now average acceleration, the same definition will continue to the same equation also will continue. Now A is equals to v by t. Now average means we are taken, the clear we are taken, but average velocity is equals to average displacement by the average velocity by time period. Average acceleration is equals to average velocity by time period also we can know that. The same definition will continue and same equation also will continue to it. A is equals to v by t. V by t. Clearly, now average acceleration, the mainly we can introduce it to, there are one symmetry graph. Now this is the graph, the x axis to y axis. at x-axis to y-axis. This is the origin point. Clear? This is the graph part. Okay. For example, this is the position P1. For example, at position P1. Okay. Now direction is position. This velocity v1. Position P1, velocity v1. Now secondary position also we can applicable. Here this is the secondary position to P. At P. This is the direction. At V2 velocity. Clear? At V2 velocity. There are two positions. We can know that in our previous topic which can be vector addition at an tail method. Okay? In at an tail method. At an tail method. The first one at V1 direction. This is the direction of V1. Now secondary direction. This is the secondary direction at V2. Okay? So whose direction they are applicable? This third one, delta V. Okay? V1, V2, delta. Previously we know that vector addition. The addition of vector also we can know that the same head and tail method. In head and tail method we can introduce the first velocity. This is the position of first velocity V1 and position of second velocity V2. There are two different types of same address they are taken as the direction one. The direction one first one V1, second one V2. There are two directions we can applicable in this head and tail method. Okay, now first one V1, the same direction is V1, V1, V2 into V2. Clearly, the application of resultant one delta V. Okay, now delta V is equals to V1 and V2. Now this is the average acceleration. Now average acceleration, sum of equation parameters we can know that. Okay, now A is equals to V by T mass. Okay, now this one in equation manner. Now A is equals to V by T. Now that means the acceleration. Clearly, now average acceleration means we are taking as delta function. We are applicable. Which function? Now delta function we can applicable. Now this delta function, delta A is equals to. Okay. Now average acceleration. Clearly, A is equals to delta V by delta T. Now this is the equation. Delta means we are applicable to average function. The rate of change of velocity is known as acceleration. Delta V by delta T is equals to eighth function. Okay, delta V by delta T is equals to. Clear? In x-axis to y-axis. Now what is the repetition? Okay, now A is equals to. Okay, delta Vx into I cap plus delta Vy into j cap by delta T. For previous same statements, the same equation will be continuous. Now displacement, velocity, acceleration. Clear? Now A is equals to separation delta Vx by delta T into I cap first one plus delta V into y-axis delta T into j. Clear? The rate of change of velocity is known as acceleration. The rate of change of velocity is known as acceleration with respect to I and j. Now A is equals to, okay, A is equals to Ax into I cap, Ay into j cap. Now this is the average acceleration. A is equals to Ax into y cap plus Ay into j cap. Okay. Now magnitude of average acceleration. Okay. Magnitude of average acceleration. Now what is the magnitude function? Previously same introducing our position, velocity, displacement function and acceleration also we can introduce. Okay. Now mod A bar is equals to, there are two incredible positions, Ax and Ay. Square root of Ax square plus ay square. Now this is the magnitude function. Clear? Okay, this is the magnitude function. Which one? Average acceleration we can take it as a is equals to delta v by delta t at vx plus vy. Okay, delta vx by delta t, delta v by delta t. Now we are taking the rate of change of velocity is known as acceleration. The rate of change of velocity is known as acceleration. That x-axis to y-axis. Now in magnitude one we are taking as mod a bar is equals to square root of ax square plus ay square. Okay, now this is the average acceleration. Now what is the direction? The direction we can represent it at same velocity and same acceleration. Same velocity and same acceleration. Now this is the direction purpose. In average acceleration. In average acceleration. Clearly? Now next one, instantaneous acceleration. Now what is instantaneous acceleration? Instantaneous means what is instantaneous? An instant of time period. Which one? Instant of time period. Now instant means we can take as there are three separation of graphs we can be using in our topic. Clear? Okay. Now what is the definition of instantaneous acceleration? Instantaneous acceleration. Instantaneous acceleration. Okay. Now instantaneous acceleration. The ratio of which one? Average acceleration, average velocity and time period. Which one? Average velocity and time period. The ratio of average velocity and time period is known as instantaneous acceleration. Okay, same time, same definition we continue to. Now instantaneous acceleration also we are taken as velocity by time period. Okay, there are three different types of graphs we can use in our instantaneous acceleration. Now first graph. At x-axis to y-axis. Our previous one, this one. This is the origin point. Okay. Now first position. So this is the first position for example. Position P1. The velocity we can be using velocity V1. Again we are using secondary position. Position P2. Okay. Velocity V. Velocity V. Now what is head and tail method? Okay. In head and tail method, the first one velocity V1, this one. Same. Okay. Now velocity, sorry, we take as in our parallel situation. Clearly, you know that this velocity V1. Now secondary one velocity V2. Okay, those the intersecting point. This is the delta V point. Clear? Head and tail. Okay. Now second one. In x-axis to y-axis. X-axis to y-axis. Horizontal point. The same one, the same position we can take in. Same position. Now first position P1. P1 first position. Velocity V1. For example, this is the P2 position. Velocity V. In head and tail method. Now velocity V1. Okay. Now this one is velocity V. Delta. Here, the shortest one we can take as the secondary one. Okay, and the last one at instant of time period. Instant of time period at x-axis to y-axis, origin point. Okay. Now this is the position we can take as only singular one position. The position we can take it as this is the T1 position. T1 position. Again we can introducing this is the tangential one. Okay, so these position we can take as tangential one. Now the direction we can take as this is the direction of acceleration direction. Okay, now this is the direction we can take as this is the direction. The direction is acceleration direction. So these one acceleration direction. Clearly, now A is the acceleration direction. The direction can be applicable only one singular statement we can applicable same as the singular statement opposite to the sign. Clear? Opposite to the sign. This is the tangential one. Tangential which we can take as only tan representation function we can applicable only for instant of time period. Our previous class we can take it as instantaneous velocity. Same we can using our last graph we can introducing only tan representation, tangential representation. Same as we can introducing. This is the statement of this position. Okay, the direction we can take it as this is the direction one. This is the tangential one. Clearly, now this is the instantaneous acceleration. Clearly, we know that instantaneous acceleration. Okay. Now the next one, magnitude of instantaneous acceleration. Now what is the magnitude? These three statements are three combos we can apply. Now what is magnitude of instantaneous time period? Instantaneous time. Now what is the magnitude and direction? There are two initial ones we can introduce it in the same one. Now next one, magnitude of average acceleration. Magnitude of instantaneous acceleration. Magnitude of instantaneous acceleration. Now what is the magnitude? The magnitude we can take as magnitude. Okay. Now instantaneous we can take as limit delta t tends to 0 with acceleration a bar. The acceleration a bar a is equals to limitation of at delta t tends to 0. The acceleration means we are taking as the rate of change of velocity. Okay. Now we are taking delta v by delta t. Delta v by delta t. Clearly? Okay. Now we are going to is equals to dv by dt. The rate of change of velocity is known as acceleration. Clear one? Now we are applicable limitation of delta t tends to 0. Okay, at x to y representation. Delta v x-axis into I cap plus delta v at y-axis into j cap by delta t. Okay, in separation, limitation of delta t tends to 0, delta vx by delta t into I cap. Now first one, plus limitation of delta t tends to 0 at delta vy by delta t into j. The rate of change of velocity is known as acceleration. In case you can take it as delta v by delta t equals to dv by dt. Okay, dvx by dt into I cap plus dvy by dt into j. Now the first one, second. Clear? The rate of change of velocity is known as acceleration. Okay. ax into y cap plus ay into j cap in a bar. A is equals to. Now this is the instantaneous acceleration at instant of time period. Now what is the direction? Now direction on direction. What is the direction? We are taken at the secondary to primary one. The secondary we are taken at ay by ax representation. Okay. Now tan theta is equals to which we are taken as ay by ax. Clearly we taken as theta is equals to tan inverse of ay by ax. Now this is the direction of instantaneous acceleration. This is the direction of instantaneous acceleration. We know that the point we can take as, now this is the instantaneous acceleration. Clear? Now